2,000 years ago, the ancient Greek civilization was among the most advanced on the planet. But the incredible sophistication of the Greeks at the time did not exempt them from believing the supernatural in gods and demons. Indeed, the Greek mythology left its mark on people throughout Europe, and to this day, it remains part of our culture. So it's not surprising in the slightest that the Pythia, a character born in ancient Greece, inspired Pyth Network, which we'll be talking about today. Some of you may wonder exactly what a Pythia is. Pythia. The Pythia was a prophetess who lived in Delphi in the temple of Apollo, the god of art and music. And for an entire millennium, the Pythia's duty was to give advice to those who asked her in exchange for an offering. Because when they answered, the Pythias were supposed to simply transmit advice and prophecies given by the gods. The Pythia was therefore what we call an oracle, someone who gave advice and information that was deemed reliable, in her case because the answers she gave were divine in nature. And for that reason, many Greek heads of state at the time sought the advice of this priestess, even on important matters. King Croesus of Lydia, for example, asked the Pythia whether he should go to war against the Persian Empire. Today, no one goes on a pilgrimage to the Temple of Delphi to get prophecies, let alone to find out about the price of Bitcoin. And yet we hear a lot about oracles in the blockchain world. Modern oracles and ancient oracles obviously play a similar role. The Pythia gave prophecies and advice. In other words, she was an information provider for those who consulted her. And modern oracles are information sources as well, the difference being that they do not pretend they are God's emissaries. Instead, blockchain oracles simply pass on information that they have found somewhere else. Currently, the majority of oracles we see in the crypto world offer information about the prices of certain assets, but there could be oracles that transmit information such as the temperature and humidity levels at certain locations, for example. It's just that these kinds of oracles are not particularly popular at the moment because the blockchain world has not yet really become part of our daily lives. Today in 2022, the blockchain still primarily is a financial instrument, so it's only logical that the oracles on the blockchain mainly transmit financial information. Some of the best known oracles in crypto include Chainlink, which is one of the oldest projects based on this concept, but there's plenty of others like Band Protocol, Telor, and so on. And many of these projects, such as Chainlink, have been created with a philosophy similar to that of Bitcoin. They are designed to be decentralized and to allow anyone to participate and provide information to network users. These oracles, which can be described as networks comprising so-called reporter nodes, don't always offer users what they really need. Indeed, the reporters who contribute to these networks have to fetch information from other platforms, sometimes from aggregators who have copied information from elsewhere themselves. And we end up with a kind of large-scale digital word-of-mouth process which provides results that aren't always very convincing. Firstly, since the participants send information that they didn't necessarily verify themselves, sometimes they send erroneous data, even if they are honest and doing their best, because the source they had chosen lied to them, or sometimes because that source itself accidentally propagated a lie or something inaccurate. Secondly, of course, there is a problem, which is the inherent delay in the process of information transmission. In the financial markets, it's important to get information as quickly as possible, and with fully decentralized networks, we cannot always guarantee that this information will reach users on time because it follows a fairly long path. In order for an oracle to display the price of Bitcoin at any given time, for example, transactions must take place first. The exchange platform that manages these transactions will then determine which orders have not yet been triggered in the order book, and then determine which are the highest buy orders and the lowest sell orders. A price will be determined based on the last trade made, while also taking into account the remaining buy and sell orders. The price is then displayed on the website and can be viewed by users. Among these users, there may be an aggregator which will receive the data produced by the exchange platform with a slight delay due to its internet connection, and which will display it on its own website. Then, one of the participants in the Oracle network will look at the data displayed by the aggregator, again with an additional delay due to its internet connection, and they'll transfer it to a consensus node in the Oracle network. And you guessed it, there is yet another additional delay between the information provider and the consensus node. After all this, once the information has reached the consensus nodes, there is a small discussion between them to determine the final price displayed by the network according to all the data received, which takes some time. Again. And finally, when they reach a decision, they publish the information on the blockchain in a block that may or may not be published immediately. On the Ethereum 1.0 chain, if a block has just been found and the Oracle network wants to publish the price of Bitcoin, it will take 10 to 15 seconds for the next block to be validated. It all sounds mostly okay when you hear the whole process explained like that, but there's actually a major problem which will illustrate with a short trip to ancient Greece. Imagine that you are a King Croesus, which I mentioned earlier, and you go and ask the Pythia whether you should go to war against the Persian Empire or not. You wait patiently for the answer to come. During 40 years you keep waiting and you die of old age without receiving the answer. Your son becomes king, waits, and dies of old age without receiving it. The kingdom of Lydia collapses, and so does the Persian Empire. And then on a beautiful day in 2022, a very distant relative receives a parchment in his mailbox which says, "If you cross the river, a great empire will be destroyed." And it's completely useless to him at best. So that's the problem with data that was transmitted slowly. Every piece of information has an expiry date, and it can become completely useless after some time has passed. But in the financial world, 15 seconds is absolutely huge, as if centuries had passed. In 15 seconds, the price can drop by 80% during a flash crash, and if you're not immediately informed when such an event occurs, it can cause a lot of problems. So of course, Ethereum 1.0 is currently the least efficient of the big smart contract platforms, and the problem is less noticeable on chains based on Cosmos or Polkadot, for example. But in general, it remains true that reporter Oracle networks can never have perfect transmission times because the number of steps between the birth of the information and its arrival on the network will always be relatively high. So what other solution is there? So far, I've described the principle of a reporter Oracle network, but it's not the only model out there. There's also publisher Oracle networks, that is to say, networks that require their participants to be the primary source of information. There is no need to waste time with all this word-of-mouth stuff, because in a publisher network, it is the trading platform itself that will directly give the price information to the Oracle network. Sometimes the price information can also be provided by someone who trades a lot on that platform. And so we finally get to this video's main topic, since it is that publisher Oracle network that was chosen by the creators of Pyth Network. The Pythia was a direct link to the gods, and Pyth Network is a direct link to the place where trading happens. The team chose this architecture because existing crypto oracles were not competitive enough against centralized oracles when it comes to certain purposes. Before, you had the choice between using a decentralized network that wasn't too expensive but provided information that was sometimes a bit too old, or selling your internal organs to pay for a few specialized services from the traditional financial world. For some use cases, the old-fashioned crypto oracles were sufficient, but when it came to high-frequency trading on decentralized exchange platforms, it was not always fast enough. This is why the Pyth Network was born. It serves to increase the number of possibilities for creators of decentralized finance applications, for whom sometimes extreme speed is a requirement and not simply a bonus. With this basic concept of providing information directly from the source as quickly as possible, Pyth Network was launched in August 2021 and currently has 50 participants who are sending their data directly to the network. Just look at this list. Alameda Research, Bitstamp, CMS Holdings, which we have interviewed on the Journal du Coin's YouTube channel, FTX, which was to be expected since Alameda is in the list, Gate.io, Jump Trading, Radium, Serum, 3 Arrows Capital, 0x, and that's only the big shots from the crypto world. Because in addition to that, there's also companies like CTC and LMAX Group, which belong to the world of traditional finance, and they are major players over there. So on Pyth Network, we have a bunch of hand-picked primary sources of information coming from the crypto world and the TradFi world. They have both the freshest information and the powerful servers that are required to send it as fast as possible. So now there's only one major question left. Of all those available right now, which blockchain was chosen as the Oracle Network's information repository? Since FTX, Alameda, Serum and Radium are on the list, you guessed it, the blockchain used by Pyth Network is none other than Solana. A network chosen, of course, for its Formula 1-like performance, incredibly fast and... yeah, maybe it's best not to overthink that metaphor, but hey. Solana remains an extremely fast network most of the time, so it's certainly one of the best choices for an Oracle system that wants to be number one in the information race. However, this is not the only place where Pyth Network will publish its data. Thanks to the Wormhole bridge, the data aggregated and published by Pyth Network on Solana is then transferred to Ethereum and Terra. And soon, it should also be possible to transfer it to the Avalanche, Oasis and Polygon networks, for example, since they are already compatible with the Wormhole system. Of course, this additional step represents an additional delay and therefore reduces the value of the information transmitted once it reaches the other network. However, all things considered, Pyth Network still remains an interchain Oracle network that benefits from its publisher Oracle architecture. It's therefore interesting to use, even if it's not quite as fast as it could be if it were directly implemented on these other chains as well. Unfortunately, directly sending data to other networks is not possible at the moment since Pyth Network is not an independent network despite the name. It is in fact an application directly built on top of Solana. There are no dedicated Pyth Network chains or block validators that work only on Pyth Network, so Pyth Network is married to Solana in sickness and in health. And since we're talking about the network structure, let's see how the data published on the Pyth Network is managed. The official diagram is useful because it shows all the mechanisms at once, but it's fairly complicated at a first glance. A few explanations are required to really understand it. So let's start with the three types of network users which are located in the blue text bubbles on the diagram. First, there are the publishers, which simply are the people who will send information to the network. On Pyth, publishers are all those companies that I mentioned earlier, exchange platforms, investment funds, and so on. These data providers are rewarded by the protocol according to the amount of information they share with the network. Then, there are the delegators at the top left of the diagram. These are people who hold Pyth tokens and have chosen to stake them. Indeed, the network is designed so that data providers are rewarded not only according to the amount of data shared, but also according to the value of the assets placed as collateral by the delegators. If a delegator believes that the publisher offers reliable data on a particular topic, such as the price of Bitcoin on the BTC-USDT pair, then the delegator can stake their tokens to increase the influence of that publisher on that specific topic. When several data providers send information about the same assets, by default the network assumes they all have an equal amount of influence. But if a delegator vouches for the information provided by one of these publishers, then the information that publisher sends will be deemed more important than the information provided by the others. This system makes it possible to take away any influence on the network from data providers that the delegators do not consider to be reliable. Indeed, if no one vouches for one of these publishers, then the data they send will have almost no influence on the final result that is shown to the public. So it can be said that delegators' mission is to separate the wheat from the chaff. Finally, the last type of actor that's on the network is obviously the consumers, who in practice will not really be consumers in the broad sense, not people, but rather applications, decentralized or not, which will use Pyth Network autonomously. Consumers on the Pyth Network will be able to read the data streams provided by the network and possibly pay a fee if there is one. Finally, it should of course be mentioned that network participants will be able to sit in several of those seats at the same time. A data provider may also be a delegator who helps secure the network as well as a consumer. However, at the moment, Pyth Network does not yet function exactly as I just described. The team has not yet created and sold the Pyth token, which is to be used for staking, paying fees if required, and paying data providers, among other things. All these mechanisms will only be visible once the token goes live. And at the moment, nothing has been announced except that there will be a token one day. That being said, if you want to see Pyth in action and look at some of the information provided by the network, you can do so quite easily by going to their website, since there's a page that displays all the information feeds they have in real time. You can find crypto, stocks, forex and metals, all live and on Solana. Lastly, if you like math, you can also take the time to read a few articles on their Medium page like this one, which explains what a confidence interval is and how it is used to calculate prices on Pyth Network. And now that you've got everything you need to understand Pyth Network, we'll be waiting for you to join us on Discord, Telegram and Twitter. See you soon!